Okay, now I'm audible. Perhaps if I turn my microphone on. Hey everyone, good to see you all for day 2 of Hot Chips. If you're rejoining from yesterday, good on you. For those who are watching this live stream after the fact, then here's the timetable for the day, and the first session starts in about half an hour. So if you fast forward through the stream to about half an hour in, you'll get into the inference section. You still got no audio? I'm not sure how much of a delay there is on the stream. Okay, yay, day 2. Right, so we have, first up is machine learning and AI. That's inference chips. Then we have a keynote from Department of Energy, DoE. Then a small half-an-hour break. Then it's the big chips. This is where we talk about Cerebras and Graphcore. Then we have lunch. Then we have graphics, which is where we talk about Ponte, Vecchio and RDNA2. Then another break. Then new technologies, which is quantum, and then the end. Sweet. And again, thank you all for joining. One of the biggest requests from the stream yesterday was we have a timer, so I've managed to figure out how to put one out, so we know exactly what time it is, so when everything starts. So you should be able to sync up with what we're doing during the day. I went out this morning and got myself some bubble tea. Nice bit of rose and aloe, though we don't often have bubble tea places in the UK. There's more in London, but I'm glad I've got this. Nice and refreshing. So how you're doing? Did you all get enough sleep? I think I got a good 7.5 hours, but then, straight back onto the grindstone. And the results out of yesterday seem pretty good. I think we had subtotal of about 15,000 views during the stream. And then for a funny thing, actually, YouTube kind of demonetized the stream. It's limited monetization, so I've put it for a review, and we'll see how well that does. But yeah, how are you guys doing? Yesterday, I've been thinking about what sort of content can we do that came out of yesterday, and there's definitely something to be said for IBM's new virtual L3, L4 caching. I'd like to do a short video on that. My Samsung DDR5 short video, it's only 7 minutes, has done really well. So that might be sort of good push out content for stuff out of Hot Chips. To go more than 7 minutes, you really have to do a lot more research into some of these things. So, but cool. I've still got the Watsits. I've still got the. I'm not sure if I'll actually open this today. I did have a very big breakfast, so we'll see how lunch goes. Though we'll either snack into these, or we have the Karma Bites, the Peri Peri Karma Bites. Everything's coming up Peri Peri, I think. So it's funny trying to balance packets of crisps, packets of chips on a desk. Doesn't really work. Another request I got yesterday was to make the chat on this side of the screen a bit smaller, so you can fit more in, fit more names, fit some of the longer contents out. So funny thing is, with the Samsung DDR5, I did that very small video, and they reached out and said, even though they'll be able to start mass production by the end of the year, that doesn't necessarily mean they will. So that is what it is. Though I did reach out and say, well, when you got some ready, let me know. I want a couple. So we'll see if they send out. With regards to the HBM PIM, yeah, they can send. Some of that stuff is cool just to have, to see. Though it's like the atomic clock PCIe card. I won't necessarily know much what to do with it. In actual fact, I've got a neuromorphic board, FPGA board over there with some of Intel's chips I want to do some content on. But I haven't had a chance to play with that, and there's no way I'm going to be able to turn it on and find out exactly what I need to do. I need to start the AnandTech live blog. Just if I start it a bit early here, then we'll be ready to go. It's going to take a minute or two. So first up with machine learning inference, we've got Esperanto with a RISC-V SoC, Enflame, which is a really big Chinese company that's got a lot of venture capital funding, and then Qualcomm's going to show off its Cloud AI 100 chip. So let's see if the live blog is working. So then I can sort it out in stream. Then it starts at 8:30 AM Pacific. So about 22 minutes. Link. And let's stick it in the stream. So yeah, this is going to be the box for today. Similar sort of thing to yesterday. I haven't got studio mode on, so let's do it live. And yeah, this will be the first one up. The Esperanto chip seems interesting. They keep emailing me to talk to me, so we'll see what happens with that. It's meant to be a 1000 RISC-V core SoC. Oh, very was good. The Enflame chip, because that's going to be completely new and might be out of left field. We'll see what they're doing over there. They've got a lot of money behind that company, so we'll see what happens there. And then Cloud AI 100 from Qualcomm. That's been out for a little while, so, or at least it's been talked about for a little while. They spoke about it at their tech day in December, spoken about it before then as well. So I think we're going to see more of a bit of a rollout. And hi to everyone joining the stream. Let's see if some of the people from yesterday come in. I think we saw John Masters, Dan Ernst, a few others. Crispy Silicon is saying the audio sync is better today. That's good. That's very good. I just need to log into my email here. They've people have been emailing me all yesterday, and they were saying, "Can you respond?" And it's like, well, no, I'm in the middle of a live stream. So, but yeah, I think the fact that Sapphire Rapids won't support CXL.mem, that's probably worth a small bit of content. EV Bike Dude, interested to see how these compare to Tesla D1. To be honest, the only thing that's comparable to Dojo is going to be Cerebras. I've been pre-briefed on the Cerebras stuff. It's going to be fun because it actually makes more sense. It puts Wave to Scale Engine 2 in a bigger context. Let's put it that way. They design that thing for scale out. So, hi Jiming, hi Spaghetti Code. What chips are everybody eating? What chips is everybody eating today? What crisps is everybody eating? To be honest, Tesla perhaps would have been accepted for a paper with their Dojo. It's just the fact that they announced it a few days ago at their own event. And one could argue that that got them better coverage. So we'll see. the one thing maybe we can see, I need to go to AnandTech. If everybody goes to the AnandTech live blog, I'll find a picture that I want to show everyone, right? If you want an AI built chip t-shirt, then you need to go to this link and follow the QR code. I do need to. I need to follow the QR code. I don't actually have a QR code scanner on this phone. Let's try on this one. Barcode scanner. I think everybody wants a free t-shirt, don't they? Okay. cutt.ly/hot-chips-giveaway. So let's put that in. Yeah. Okay. Here's the link if you want to get a free t-shirt from Synopsys. I'm going to fill it in now. Oh, please note that qualifiers must reside in the US. Let's see. We'll see if they'll ship me one. And of course, it's probably an American large. Yep, let's see if they'll send me a t-shirt then with an AI chip. It says US only, but I don't know. Hot Chips is meant to be international conference. Just stick it in. Just stick your address in, and if they send you one, they send you one. If they don't, they don't. We'll see. That's what I've done. I'm based in the UK, so we'll see if they send me anything. Can't hurt not to, really. I only asked for 30% sugar in my bubble tea, but it's really, really moreish. That guy on the right, ED Bite Dude, is the CEO of Synopsys. I'm actually interviewing him on Thursday. So, hey, John's in the chat. I find it best in this line of work to have a bunch of people that you know worldwide that can accept localized parcels for you. Thing is, when they give away these t-shirts, I do wonder. I mean, a couple of companies are doing it this year at the show. How many they expect to be made, to be sold, to go? Because on the one hand, they kind of expect it only to be for people at the show, but then everybody who's like watching the stream who isn't a member of the show, for example, can go get, can click the link or whatever. So, the only issue you have of putting in your international address may be that you have to pay some sort of duty on it, import duty. So, thanks, Jax, for the £5. I would love to see you sponsor Hot Chips next year too. So technically, I'm not a sponsor this year, just to be clear. This is just for sponsorship next year. That's the goal. Though Stream OBS Labs, the donation thing, which will be up in the corner, isn't necessarily working that well. But yeah, hopefully we'll get to see the logo at Hot Chips next year. Let's see. Yeah, everybody enjoy a free t-shirt. The gold bars on my other scene, I haven't put it up on the main one. So EV Bike Dude says the handling charge from the courier might be the worst. Yeah, in the UK, you pay whatever your import tax is, so 20%, plus that also applies to the postage, and then you also pay a £12 fee from Royal Mail, regardless. Moshe says you need an appropriate business email. It's whitelisted domains. So my AnandTech.com worked. EDU should work. I will ping the Synopsys people if the EDU doesn't work, because this is a conference for students. So Evan, let me see if I can ping them now. Email address rejected. Who else is getting a Gmail blocked? Okay. Is it worth putting it in a Slack, do you think, John?
What's your minimum specification?
Yeah, okay, I'll just put a message in Slack. So, we'll see. You're right, Elijah, it does say business email, but Hot Chips is about students, so... Hey, Celador. Well, good to see you. AJC, for whatever reason, both my universities never kept their email addresses for alumni. I wonder why it's stopping .edu then, Pascal, if those are the invalid domains. I don't know. Oh, one thing I should mention. This Machine Learning 2 talk here later in the day, the big chips, one that's got Graphcore and Cerebras in it, that also has a special Anton 3 ASIC from Sure Research for molecular modeling. It's like a dedicated piece of silicon for molecular modeling. I think that's going to be a wicked talk that you all should tune in for. Yeah, I responded to Chris Hook's message in the Slack, John, in the K1. So Sam, I'm not sure if the adding a period or a full stop inside Gmail works for Gmail itself. I don't know. Seller asks thoughts on Gamers Nexus, Gamers Nexus and Gigabyte exploding power supplies. Well, love Steve Airy Gamers Nexus for sure. Gigabyte saying bad power supplies that explode, that's bad. So, what else do you want me to say? Good things are good, bad things are bad. I need to stop requesting t-shirts. I have too many. Though I do tend to wear the same 6 or 7 on stream. It's because I wear them until they die. That's all right, John. You've got your meeting. We should be starting here in about 5 minutes. So let me get the everything started up on my side for the live blogs. And now we should switch over to the watch party scene. I'm going to move this down so we have the live blog visible. Well, ARPA, I'm not getting paid, no product play. This is just happens to be all the hot stuff I've got right now. I'm already halfway through. Alex, what do you expect to see from the ML and AI discussions? A lot of inference chips, a lot of training chips. There's going to be some fun stuff. Crispy, they do sell Cheetos. I don't necessarily like them, especially the flaming hot ones. Oh, I know what I didn't buy. I didn't buy my flaming hot Monster Munch. And that's because there's literally a sign outside the post office around the corner that says the post office has been shut due to an antisocial behavioral order. So anybody in the UK will know that ASBOs used to be a thing. My post office is shut because of an ASBO right now. And as Rune says, yeah, perfectly fine t-shirts, barely 10 years old. The issue I have is that the collars tend to go very quickly. I'm not sure how it's because how I'm wearing them or just because I sweat around my neck a lot or I think I need to find a way to keep the collars done proper. So, because also on camera they can look if you've got an offy collar, it doesn't look great on camera. Maybe during the lunch break, if I've got time, I'll see if I can pop out to get some flaming hot Monster Munch. I have no idea how. the post office has an ASBO. I've got a picture. Yes, I did, John. My post office is shut because of an ASBO. I'll send you the photo over Twitter later. It seems stupid. I think it's a family who run it, and it's like a father and his 3 sons, and the 3 sons are in their late teens, early 20s, so they could be, I don't know. Abstract Custom, they only qualify as car polish rag if you own a car. Okay, John, I'll send you the picture over Twitter. I read it briefly as I went by. I think it definitely looks like an ASBO, but maybe you can tell me otherwise. Actually, I need to fast charge my phone. Good. No, it's the place was following COVID guidelines, I think. So, on the screen outside, it says that they have to appear in front of the magistrate's court tomorrow. So. And yay, Tadashi has retweeted the live blog. Okay, we should be going here in about a minute or so. I'm waiting for it to start. If I can spell. Gigabyte's a big company, Wallapa. They have about 20 different business units that are effectively individual companies inside the one header of Gigabyte. So Steve and I were having a mini discussion on Twitter about companies that size. Okay, here we go. Time to start. So Dave Ditzel from Esperanto is first up. 6 years at Intel, VP of Hybrid. I keep getting emails to talk with the founder of Esperanto, so. Janus in the chat, that might be it. Okay. TSMC 7 nanometer. ET minion with 10C units. 60 million bytes of SRAM. Watch. PCIe Gen 4x8. Up to 200 tera ops. And 20 watts for inference. Focus on recommendation models. Traditionally run on x86. These servers need adding cards. Low power budget per card. Multiple data type support. Dense and sparse workloads. Be programmable. Reduced off by memory references. I assume they've been working with the CSP delete. But I expect that's also part of the presentation. Fixed function hardware can quickly become obsolete. Which is fun because x86 is meant to be programmable hardware. Now, why Esperanto has a better approach? Let's see. Avoiding using one big hot chip. Use multiple low power chips in the same power. Because you have multiple chips, you can equip multiple DRAM, therefore increasing your I/O bandwidth. Again, we've got another slide that's just slowly going through, and they're not going to tell me when the slide is at the end, so I'll miss it, probably. Whereas machine learning does well with dense, but not with sparse compute. Esperanto can do sparse compute. I'm going to hear that a lot today. It's technically Esperanto Technologies, Celador. Technically. thousands of threads. Parallelism with single big chips. Chance of risk caught in Esperanto. Large power. Recommendation in systems are interest to everybody. Think about GD and Alibaba. Post recommendation performance inside and 6 chips. Okay, here's a slide. With 20 watts for 1,000 RISC cores, you only get 10 milliwatts per core. Comparing it to big x86. This is another problem with AI chips. They always compare themselves to x86. x86 is a market leader rather than comparing them against other, AI cores. So here's the comparison slide. ET minion cores will. Down voltage per core. That might just not be me talking. Sorry, I'm trying to focus on lots of things. Efficiency versus voltage. 0.34 is best. Inferences per second per watt. One chip could use at peak. Again, this is another slide where they keep just adding stuff to it rather than just doing it all at once. Reps up, it's virtual this year, usually in person. Next year, it's probably going to be a hybrid. Keeps adding stuff to this slide, and I keep taking screenshots of it. I'm not going to be able to do a live stream if I'm there in person next year. That's going to be tough. Oh, okay. 64-bit RISC-V processor. Software configurable L1 data cache. In order pipeline. To SMT2. James, it's all on the stream. Look at the bottom right. It's a paid conference, so either you pay to see or you follow along with me. 300 megahertz, 2 gigahertz. Can do 64 ops on one tensor instruction. Sorry, 64K ops. Ricky Lake. Responding to chat. Mm. 500-bit wide integer per cycle or 256-bit wide floating point per cycle. Is that per core or is that per chip? That's per core. Eight cores on a chip form a neighborhood. Before wire length became a problem. 8 minions share a single large instruction cache. More efficient than having each core with its own iCache. Cooperative loads. Custom instructions. Now we've got minion shires now. 4 neighborhoods equals a shire. With 4 megabyte of shared SRAM. Mesh interconnect on each. SRAM banks could be partitioned as private L2 or shared L3. And then you have meshes run over the cores. Well, I mean, they could have put the mesh in the corner, mesh stop in the corner. That would be easier to see. Source that 16 LPDDR4X controllers. Oh, excuse me. Yeah, so 256-bit wide LPDDR4X. 6 chips and 24 LPDDR4 chips on a PCIe card with a PCIe switch. 192 gigabytes of accelerator memory. 822 gigabytes second total memory bandwidth per PCIe card. So 96 memory channels on a single card. OCP versions. How to deploy at scale. So 6 chips have a single heat spreader. Deploy millions of our chips. Please. Please. And yeah, good to see mega transfers per second on these slides. So you've got to use their software stack, which is usually the case with these AI chips. Esperanto predicted performance. So these are all estimate performance for Esperanto. So they are taking the TDP of the Xeon Platinum in this slide, in this performance comparison. Yeah, they're taking full TDP. not actual power consumption. And this. They have silicon, but they haven't published data. No, the stream has stopped. Or the AnandTech page has stopped. There we go. And then hit, and then for high performance Maxions. Full RV64GC processor. And here's what the chip looks like. 24 billion transistors, 578mm squared, 89 mask layers. So yeah, all results based. So there you go, delete. First silicon is now in bring up. So they're currently bring up of A0 silicon in test. Highest performance RISC-V chip, commercial chip to date. That's what they're saying anyway. Early access for qualified customers later in 2021. Moshe, they mask layers for this chip. Other chips may use more masks or fewer masks. We don't know how many metal layers this has. So Planet 886, thanks to 3,000 Taiwanese. Wow, cheers, man. Money to rebrand hot chips and hot potato chips. What do you want to rebrand it to? To hot potato chips?
What's your minimum specification?
No, thanks, man. That's like $100. Insane. So the 20 watts includes the IOs and the DRAM and the PCIe switch, I imagine. That's what it's saying. So they're not using BFlow 16 because it's mostly an inference chip, and their main customer for this didn't need it. So to save area. So the question was about cache size, given that it's a general chip, how do you cater for that? They said that because they needed to get a specific voltage, they had slightly larger SRAM cells, and then the 4 kilobyte L1 with the size of the L2 gave them a good hit rate for the performance they needed. The main thing was to be able to have that very low voltage. So next talk is Enflame. First generation. Designed 2018, launched 2019. DTU 1.0. 18 teraflop of default 16, 12 nanometer FinFET, 14.1 billion transistors, 200 gigabyte second interconnect. Hey Adam, how's it going? Sorry I won't be able to bug in on PC World Full Nerd today because I'll be doing this. Make sure when you finish that you filter everybody over to the Hot Chips talk, though knowing when exactly that happens will probably be during my lunch. Let's see. I think the right question for this chip is, how hot is it? Oh, what's the power consumption? $300. 2 HBM2 at 32 AI compute cores on chip network. But you can see it's 4 clusters of 8 tensor units. $40 data transfer engines. Adam, they're blues. Cherry MX blues. It's a Rosewell Arcade 9100, 8100 keyboard from like 8 years ago. So 256 tensor compute kernels. Each kernel can support all operations. and introduce sparsity for power. Can fully skip instructions if zero power instruction detected. So if the data is 0 times 0 plus 0. I'm running RTX voice. That's why it sounds tinny, because I've got a massive fan on me. Vector and scalar support sum and pooling.
What's your minimum specification?
Cellar door. A lot of smokers in China, surprisingly or not. So hardware can add adding elements to get best efficiency combined with zero power instruction detection. My typing is atrocious today already. Talking a lot about matrix compute right now. A little bit beyond me. Support various tensor shapes. But you have to have it on a power of 2 boundary. That's why you sometimes see padding being mentioned. Because if your matrix isn't perfectly power of 2, you need to pad it out. Level 0 cache. 10 terabytes per second. Sure. Async data flow and a compute pipeline. It's VLIW, John. For D10 sets. Supports dimension reshape. It's a custom protocol with sub-microsecond latency. Yeah, VLIW this is. That's called a bidirectional ring because it's not an all-to-all, is it? It's like the it's like the 8-socket Intels. You can also have layer cables for racks. OCP model. So AIC and OEM. Scale up to 2D torus pod. Is that how you get out of your first dance at your wedding, John? You sprain your foot. Took me about half an hour to finish my bubble tea. Damn. What's the next? They had a PCIe card, not a GPU seller. It's an AIC add-in card, but it's a passive one, so you have to have a server with airflow. Oh. Almost choked on my bubble tea. If I die on stream, somebody call my wife. Q&A time. So they're not selling this to the West, but you have to contact them to get interest. Next talk is Qualcomm Cloud AI 100.
What's your minimum specification?
Yeah, I asked, will you sell to the West? And they said, currently customers are Asia, but if you have interest, go to them. It's a shame. Hmm. 12 top support. And then we have another slide about what AI is and what's driving AI. Oh, Leap, was this started under you, was it? What's the hot gossip? So Qualcomm says that they're at the forefront of AI research. They're currently on their 6th generation chip. So obviously they've had it all the way through since Snapdragon 820. That's a dual M.2 slot. I think Will in the chat's got the right idea. So here's the architecture slide. Top level SoC slide. Bespoke, high performance architecture. 400 plus int 8 tops. 8 lanes of PCIe 4.0. 136 gigabytes per second of LPDDR4. So all the weights on the SoC with 144 megabytes of on-chip memory. 144 megabytes. We're seeing chips with 800 plus. I mentioned the controller. So it's a 4-way VLIW. These 100 plus instructions. SMT scalar core. FP32, FP16 intake, in16. Megabytes of L2 cache. Tightly coupled memory. Vector unit. Tensor unit. So vector tightly coupled memory. 8 megabyte between all units, all vector units, or almost all. So it has what, 16 of these, 18 of these? Can run it at various power levels. Seven nanometer. Tensor unit is 5 times more efficient than the vector unit. Johto, yeah, there's configurable floating point 8-bit. Search for CFP8. Yeah, 16 AI cores. That's what it says here. Also says in the SoC diagram, as Dilip says in chat. Alexander, it's slow mode because I'm not always paying attention. So 5 tops for what at high performance? A 70 watt is also PCIe without a 6-pin connector. What's the int1 performance? That's what we want to see. Or what's the floating point 2 performance? FP2 or bust. Full stack for full stack for inference. I keep wanting to write integer whenever I write inference. Delete, aren't you in the Slack? Delete. Compiler supports mixed precision. Delete, I ask you a question in the Slack. Don't worry. Johto, we're basically at the point where something that's configurable will be able to support however many bits of exponent and mantissa as you need for your operation. I know Microsoft did a load of work in the sort of 12, 11, 10, 9 bit configurable floating point operations. I had a tab open about that for ages. I wanted to do a video on it. I never got around to it. You need another bubble tea, though it's probably not good for me. He's just going through this slide about different ways in which the chip works. Parallelization trade-offs. Delete. Microsoft published a blog post about it, I think 8 months ago now, maybe a couple more. There's optimizations for low power now. So minimize DDR accesses and improve performance. So reuse data as much as you can to begin before going to get. If I find the blog again, DoE Pump, I'll send it to you. A few weeks ago, I had like 8 different topics I wanted to do videos on, all in different tabs in my browser, and I saved them all to a directory with all the papers and all the information I had related to each topic, and now I can't find that directory. It's really bugging me. I mean, I don't have time to cover most of it, which is unfortunate, so... But really interesting stuff. I don't really want to find that directory with all those video ideas, because that really bothers me that I can't find it anymore. So, gonna split a network across multiple A100 cards. So up to 16 cards per system. PCI switch for peer-to-peer. You should be able to post links now, Johto. Yeah, that looks like the blog post. That looks like the blog post, Johto. Thanks. Here you go. Here's performance for you, Delete. No, he's just reading a slide. Just reading through this slide. Johto. No, I do separate stuff for Wall Street often, a couple of times a quarter. So if you want to talk about consulting rates, shoot me an email and we can talk for sure. Oh, I know what I didn't bring with me, a coffee. Gonna have to wait until after Department of Energy keynote. So here's a server versus an edge deployment. 16 cards in a server or a dual M.2 called DM.2E. $15 watts. 15 watts for that dual M.2. So scalable solution. Drink. Ugh. So your question is TDP, and basically you can sell it in firmware. So the question here is, how do you get such a high efficiency? And the answer is, it's 6th gen. They know the area really well, but it's also VLIW. So the compiler is doing a lot of lifting. That keeps the hardware simpler. So the NOC, the network on chip, it's not cache coherent. But if you enable it properly through the compiler, then you can make the chip simpler and work and get better efficiency out of it. And the 12 TOPS per watt is based on the chip level, not the board level. But you can see the question now in the live blog. Oh, I should have slept a bit more.
What's your minimum specification?
So trade-offs between VLIW and RISC use. He said that machine learning fits very well on VLIW, and they have insights that know how to do very efficient VLIW cores. But not only that, the workload is well suited for that. So they did the evaluation, and VLIW is the best way. In terms of the NOC details, whether it's a mesh or a crossbar, he said it's a hybrid. Think of it more linear, but with intermediate routers involved. So. Let's go for Pringles. Once you pop. So question is it a Sonic array? The answer is no. And the question is the scalar core RISC-V or something else? And the answer is that it's a custom scalar VLIW core. So what flavor Pringles? Paprika. Okay. Doing a 10-minute break before the keynote. So with the paprika, I heard that somebody said it's basically the same as barbecue flavor in the US. So what we call paprika, they have barbecue. Codger Face, regarding chip dust, I actually cleaned out my keyboard a little while ago. So if we're going to have a 10-minute break, I really need to get a coffee. So I'm going to throw up the break time, but back in 5-10 minutes. I'll see you all then. Okay, we're back, and we go straight into the Department of Energy. It's just about to start. I have my French vanilla instant coffee. Just starting. US government. I don't think Enflame's had a software slide, Johto. Oh, I missed that side. They never leave these things up long enough. Oh. So the US government now has a new AI office. Anyways. So he's saying that this talk is... He doesn't claim to speak for the US government. So... So we shouldn't confuse discovery and invention. It's going to be a lot of views, and I hope this is more concrete than list of reflections and what he thinks. Science and technology evolve differently, but are intertwined. Oh. Let's see how this goes. I'm going to keep reaching for these if I don't stop. technology leads science, and science leads technology. Personally, I hate using the word science as a general term is really frustrating. We really need to call it research. If you call it research, then there's a lot less backlash for people who don't like the word science, and it's like, oh, you believe in science. If you say the word research, they usually tend to have fewer qualms. And and when people say science, they often mean scientific research. So if you just call it research, it's cancels down. This is more philosophy of invention rather than actually anything about chips right now. Department of Energy is the department of everything. Now he's used the painting the Golden Gate Bridge. It's fun when people bring up the Golden Gate Bridge because I just point to the fact that the UK has a bigger bridge than the Golden Gate Bridge in the UK. It's just it's in a place called Hull. So people say, oh, it takes so long to paint the Golden Gate Bridge. Well, yeah, we've got one longer. Same sort of suspension bridge, just longer. Johto, you should be able to post links in chat now. I disabled that block. Yeah, unfortunately, Celador's right. He's saying it's a purposefully lay chat. Unfortunately, he's speaking to a very technical conference. Hey, Rogue. Everybody say hi to Rogue in chat. Janus says the bridge in Hull could be made of gold, but it's still in Hull. Yep. I spent many years in Hull. Links should be able to be posted. I don't know what Streamlabs is playing at then. Sorry. "17 national labs, workforce of 100,000, and they have all the exascale machines." It's not about being faster, it's about being smarter, basically. That's what this slide is. Provide actionable decisions. It's another long day today, Rogue. Are you doing a Tuesday stream today? I wonder if you start, whenever you start, if you go with tech and you last 2, 3, 4, 5 hours, I wonder if I'll still be streaming by the end. Unfortunately, I didn't buy any Tim Tams for the stream, Rogue. I was literally in town a few hours ago. I bought bubble tea. Didn't buy any Tim Tams. Oh, this is a busy slide. Not necessarily specialists, but know how to tackle complex problems. There are no do-overs if you are wrong. Questions are often imprecise. I tried doing a Tim Tam slam once, but it all disintegrated. Gulf oil spill, Ebola, Fukushima, satellite shoot down, underwear bomber, WikiLeaks, Iran deal, Havana syndrome, veteran suicide, and obviously the virus. So now we're talking about the exascale lift. Moving towards exascale. The first exascale is what, next year? Well, Aurora was meant to be the first one, but now it might be Frontier. Is that correct? Yeah, you wouldn't think WikiLeaks would be a Department of Energy problem, would you, Jax? Athletics move the exascale lift. DoE was hammered by Congress due to Fugaku. Ha! That's DoE does things that are viewed to be nuts, but they prove fruitful. Using PlayStation 3s at Peter scale in 2007. It's 3 years ahead of the DARPA program. Finding things for a purpose to solve problems. And these are the instruments. We at AnandTech, we actually got access to a Fugaku node. And yeah, we got hold of it, but we didn't know what to do with it. And we didn't really have enough time to test it. Really bombed hard with that with that testing. I haven't spoken to Fujitsu since. But yeah, we really bombed hard with we got argued for so long to get the hardware. We finally got it, or at least remote access to it, and then we couldn't do anything with it. Yeah. We went to jump the hurdle before we realized what was on the other side, basically. Chips. I think I'm just hungry. Well, Rogue, at least when you have a motherboard or a GPU and you don't have a CPU, you know you don't have a CPU. For us, it was we didn't have the software, but we didn't know what the software should look like either. And we had no experience of what that software should look like. So we knew we needed a thing. We didn't know what the thing was and how to look for it. It was, it was tough. And again, yeah, we came out with it with nothing. I think I've got screenshots of a few tests, but that's about it. And this slide is just learning how to solve complex problems. It's only science if you write it down. Otherwise, it's just sparkling randomness. Now we've got a slide on learning how to model. Like von Neumann. Pygo, wee! Only if wee comes with about 20 grands of hard drives or 100 grands worth of flash. Wee! I wouldn't be surprised if he's actually given this talk a dozen times in different places. Brian, yeah, you do need 4 to 8 nodes to get a glimpse of scaling, but you need to know what to run on it that will also scale. That's the thing. It's 20 minutes into this talk, and it's not really been that much about we have a foundation. Celador, if you get a chance, watch the Tesla AI Day live stream on YouTube. There's a section called Dojo. I do need to do a video on it. I really do. Will they manage the nuclear stockpile? They do a lot with natural disasters. You know, there's a slide a little while back. They dealt with WikiLeaks cables. It's Department of Energy is basically also the Department of Computing. So Argonne National Lab, Lawrence Livermore National Lab, that's all DoE. Right, they're the ones that manage all the US big supercomputers for nuclear modeling, for weather modeling. You know, they also have, you know, the weather service under their heading as well. Yeah. Our largest computer simulations stress our largest systems. Architectures have historically been developed to solve equations and not to deal with the data at tomorrow's scale. Has somebody done AI on weather systems for prediction? Johto, I think the thing about Dojo is because the chip is so... Dojo has benefits because it's only built for one company. So... Dojo for Tesla looks great because they can pull great numbers because they can optimize very specifically for their workload. Companies trying to make chips for the general market have to have a general architecture for everybody. So Celador, the goal of this presentation was meant to be sort of get the US government's point of view on chip development. Unfortunately, he started right at the beginning saying, I'm not speaking on behalf of the Department of Energy, on behalf of the US government. So he basically gutted the start of his presentation to start. I think we should wait. I think the next session with big machine learning chips and then followed by graphics is going to be a bit more interesting. I think John's right. DoE is really exciting and supercomputers is really exciting, but you really, really, really need to have somebody, a senior engineer that works at one of those places, kind of explaining as much as they can about what they do. So. So speaking about working on Fukushima, the US government asked them if they should evacuate US citizens, and they wanted a decision within an hour. Now, the problem started at 11 p.m. at night. They had to get people up, and they had to go back with an answer about whether they should evacuate 60,000 people through Tokyo airports. So, that sort of thing. Chris, we had an 11-hour live stream on Hot Chips yesterday, so it's been going. All the information is on screen. And I'm getting a little cranky because I'm a bit tired. I need more coffee. Hi, Kai. Oliver, thanks for the £5. Much appreciated, man. That's going into our Hot Chips fund. Hot Chips Sponsorship 2022 fund. Thank you. Dilip, I understand that this one was actually the Hot Chips committee reaching out to the DoE for a presentation. No metrics for how close you might be with some of these decisions at the high level. You're being told how hard NP hard is, John. If I knew this presentation was going to be this, I perhaps would have not live blogged it. He's just going over these slides. It's very, very drawn out, very long, and he's not saying anything. Now it's time for a throwaway slide. So for those asking, what does the DoE do? This is kind of what DoE does. And basically 90% of this talk has been the one in the bottom left, future of scientific discovery. JT, if I, because I'd still be live blogging it, that's the problem. If I was on location listening to this, I probably would have walked out already to go and have a chat with Charlie from Semi Accurate or something. Or the whole point of this conference really is that when there are talks like this that you're not interested in, you go to perhaps some of the sponsors' booths or some of the people who have paid to have booths there and see if they're doing anything interesting. So here they keep talking about faster simulations aren't always the answer, or just aren't the answer, full stop. Are there any questions in the Slack? No, there's a few. SambaNova. Oh boy. Okay, SambaNova's coming up later. SambaNova's involved with the DoE. I did ask a question, John, in the Slack. Basically says, when is Aurora going to be ready? Where's that Andrew Feldman in the bottom left in that slide? Cerebras? Yeah. Okay, SambaNova and Cerebras. So all the people coming up in the next session are probably deeply involved with the DoE. So So thinking beyond just the immediate market on chips. Need to do much more of this. I asked another question in the Slack, John. Yeah. My second question is, all of this, when does the DoE become an investor rather than passive? Hey, Gavin's in the chat. Oh, now he's taking about books of logarithms. Oh, this is way too high level for this conference. MT, no, it doesn't. I tend not to drink when I'm working. Unless it's the very last thing to do. And even then, probably shouldn't drink when I'm streaming. Just lots and lots of coffee. Though, this is a sort of talk where you should have a drinking game. Yes, Gavin, that's a big bag of flaming hot whatsits. And we got some paprika Pringles as well. And obviously Cheeky Nando's hot sauce. So in the 50s, you could have one person who understood everything top to bottom and could have the epiphany that could move forward. Now you need more than one person. This is a sort of presentation where if this is the first lecture you have in a class, you at university, you immediately withdraw yourself from that class and go do something that's interesting. Oh. This isn't even DoE over the course of an hour. This isn't even his vision. It's just generic waffle.
What's your minimum specification?
I think you need to move to an IV of coffee. I don't even think he's talking about abstraction. John, we used to get grades like that, A1 to E5. First one was for effort. Second one was for actual achievement. I think I got a 4A in physics, which means I tried really hard but did rubbish. That's because it was based on one test. Health worries about rare outcomes. So what, we need the hardware to do it? To predict it? This is using health data to force a rethinking of traditional paradigms by challenging ourselves with qualitatively new classes of prediction and richness of data. What? What are they doing about the chip supply shortage, Will? Well, the government is giving a big bucket of money to Intel. That was announced, what, yesterday? I don't think we know how much money Intel got. Yeah. Please say something. Will, check AnandTech's pipeline section on the right-hand side. Johto, I think the big bucket of money might end up being used to acquire Global Foundries after the IPO. Maybe. When I say it's a big bucket of money, it's probably a big bucket of tax breaks. Ryan wrote up the article over on AnandTech, so... Let's put it in here. I just don't think there hasn't been a dollar figure attached to it. It's meant to be for IFS, but we'll see. So talk about budget reconciliation in the House and a bill in the Senate that passed, CHIPS Act. There we go, summary side. Summary slide. Technically, there's what, 10 minutes left of this presentation? 8 minutes. There's plenty of Q&A. thought-provoking keynote. Q&A time. He's reminiscing about the 40s now. 40s was the last time we were transformative. So if the 40s was the last time we went top to bottom changed, it was a different time. It's just less commercial activity, lots of money. We're in the middle of a Cold War, which pushed a lot of these things. It's take the best ideas from each section and get the best answer. Oh. This is all about iterative versus step function. Oh. Yeah. There's more questions. Please finish this answer. Please. He's just wasting out time on trying to answer this question. My watch just said get up and move because I'm waiting for these questions and to be asked and the answers to be answered. So should the DoE develop its own chips or buy commercial silicon? Used to make their own silicon, but now they don't. So he's answering my question. That's why I'm kind of quiet, because I'm trying to listen. that's a wrap for the keynote. Oh, that was like pulling teeth. So the final question there was mine. It was about investing in startups. Basically said, it's the DoE. The investments are more like providing data to see if those chips will work with data, because the DoE has to have a place to exercise technologies that work for the problems they face. He did admit the DoE isn't organized enough to have more vision into the private market to do this, and they need more test beds. They need to be able to give these sort of startup companies more real data to see how effective they are at solving real problems and whether it aligns with what the DoE is doing. And at the minute, they don't have a vehicle to do that. So I at least got something useful out of him. Oh, but yeah, that was a bit painful, wasn't it? If anybody from Hot Chips Committee is watching this, let's have a chat. So yeah, let's have a chat when things like that come along. I mean, it's good to get the DoE in to talk, but let's get them to talk about stuff that I think more of what the audience is interested in. I think there was a misalignment there with what the DoE expected they would be talking to, who the DoE expected to be talking to, and a misalignment of what people at Hot Chips may have thought exactly what the DoE was going to talk about. So it's nice having a high-profile person, but if anything I've learned working in the press is that sometimes you get the high-level person who doesn't understand who they're talking to. And Kelly, thanks for the $40. And I think you've said before on the stream you're in the Marines, so yeah, once a Marine, always Marine. No such thing as an ex-Marine. It's a tough old world out there.
What's your
But
minimum specification?
I do think there could have been room for a much better DoE talk at press events where they roll out the CEO or they roll out the executive, the marketing executive, and he doesn't know anything about the products that he's talking about, or he knows enough detail to sell them, but not enough detail to the people who actually care what's going on. It's like, I need to know about your product so I can understand how you guys work and predict what you're going to be doing next. And the person who's doing the presentation doesn't know any of that because they're too busy figuring out how to sell 20,000 units to Dr. Pepper. That's been the thing that they were working an hour before they did the presentation. Sometimes the high-level name is sometimes just a name, unfortunately. I bet there were different topics that he would be great at talking at that would be more aligned to what would, but in this case, it just wasn't a good mix. Let's see. So the next talk is here, the machine learning chips. This is going to be a good session. We're going to see Graphcore, we're going to see Cerebras, we're going to see SambaNova, and one other, I think. Yeah. So small half-an-hour break now, come back in 20 minutes, and that's what I'm going to do. Because, yeah, after the bubble tea, after a coffee, I need another coffee, and just to, sort things out. So let's see you all back in 20 minutes. Hey, 3 minutes until the next session. I just had my cat sit on me for 10 of the minutes during the break. Let's see if we can get the next Hot Chips live vlog up and running. And forget which one's first. It's Graphcore first. Got myself a new coffee. And let me change the top presentation. If I can. There we go. And then Graphcore, Cerebras, SambaNova, and then the Anton 3 ASIC, which I'm really looking forward to. So for this session, it's going to be 2 hours. I got my coffee, still got my water. Actually, that needs a top up, and then a big bowl of fruit. Rather than I decided to put my hot chips out of reach, because otherwise I'll eat them all by the end of the day, and that's probably not good for me. So yeah, got some raspberries and some strawberries and some blackberries. You can always tempt me with a fruit salad. Fruit salad is always good. Oh, this David Kent is the chair for this session. So let's scroll down on the stream. Don't let me scroll down so far. I'll move it down another inch or two when we get started. But yeah, Graphcore are going to be showing off their Colossus Mk2, which they've shown off in 3 or 4 events already. So if you've been following Graphcore, you might seem very similar to what you've seen before. Can't hear you, David. Well, can barely hear you. There you go. The cantor is speaking. Don't know what David Kenter looks like. There's his mug. But he's been on lots of live streams with YouTubers recently. ML is not the only game in town. just going through the what's happening during the session. So I've already seen this video, or at least most of it. But yeah, designed for AI. New structural type of processor, the IPU. So, why do we need separate silicon for AI? Basically this. Why do we need new silicon for AI? Oh, I'm fed up of hearing this slide at the start of every AI talk. I need to turn off some of my social media. Let's talk about AI does lots. Embracing graph data through AI. Scaling has got classic scaling has ended. Oh, excuse me. That's because I have the cat on my lap before this talk. Oh, sorry. Excuse me. So now he's going to get into the weeds about graph compute. Creating hardware to solve graphs. So, way of describing mathematics for solutions. I didn't do graph theory at university, so. So control program can control the graph compute in the best way to run on specialized hardware. So hardware abstraction, tiles with processors and memory with a I/O interconnect, which they've called the exchange. So each company has their own way of naming these. I mean, IPU in this Intelligent Processing Universe is Infrastructure Processing Unit. Bulk synchronous parallel compute. So basically thread fences for communication, this is why some companies do asynchronous compute, because if you do synchronous compute, you have to do a lot of waiting around. So this is a second gen processor, real transistors on a chip. Record for real so basically they're saying that this chip has the most transistors of any chip on TSMC N7. So arguably you could say Cerebras has more, but this is within one reticle. And then 896 megabytes of SRAM on N7. And then there's some detail about capacity and stuff. So the server is, sorry, I was asking a question in the Slack. I want to forget answered, but the server pizza box is a 1U with 4 of their processors in, and then a control processor as well. Not saying much about what the control processor is, so. Lightweight proxy host. (1.2 terabit per second off chassis I/O. 800 to 1200 watt typical 0.5 1500 watt peak. Can use PyTorch TensorFlow. Onyx, but own popular software stack is preferred. And here we go, the comparisons to TPUs and GPUs. I posted my question in the wrong place. So thanks to Dr. Mario Krell for telling me where to post it properly. So here's what the chip looks like. Half the die is memory. (24 tiles, 23 are used to give redundancy. 1.325 gigahertz global clock. 823 square millimeters. Again, TSMC N7. Now we go into how each of the processors work. 32-bit instructions, single or dual issue, and then there's 2 main parts per tile. Six execution threads. Launch work threads to do the heavy lifting. Hiding the pipeline from worker threads makes vertex execution easy for the compiler to predict in its load balancing. No, did it? Oh, I thought I put in one. I can't believe I said 25. It's because I went 1.3 and it doesn't always pick up the first couple of things. Yeah, 1.325 gigahertz, not 25 gigahertz. My bad. So 47 terabit per second data side SRAM access. Well, that's a number that should be. So FP16, FP Vecchio, mat, mul, and convolutions. Strawberries are nice. CPU relies too much on large matrices for fine performance. Random number generation. Huh. I didn't get this part of the video. Each tile can generate 128 random bits per cycle. Can round down stochastically. At full speed. Void FP32 data with stochastic running. Helps minimize rounding and energy use. I can't spell rounding or minimize. So in this case, you've got compute in coral, sync in blue, and the yellow is idle. Sync. 2% cycles in compute, 30% in exchange, 10% in sync. Depends on the algorithm. Compiler load balance the processors. And that also minimizes compute to a certain point. And here we go. Use their compiler to get best performance. There can be 3 cycle difference drift cross chip. Chip power. Petajoules per flop. So there's just 60, 30, 10 again in the. Yeah. Arithmetic energy dominates. Not using HBM. 1 die SRAM, low bandwidth, 0. DDR for model capacity. HBM has a cost problem. IPU allows for 0.
What's your minimum specification?
Kelly, that might be for a different stream. But yeah, I don't think that should be a problem. What do you gigabyte of HBM triples the cost of a processor? Really? Oh, added cost of course. Enter add margin. with CoWoS. No such overhead with DDR. Dan, we know, I know, you know, off-chip DDR bandwidth suffices for streaming weight states for large models. More SRAM on chip means less DRAM bandwidth needed. That's why you see a lot of chips argue about how much onboard DRAM they have. So, chip earlier, the Qualcomm one had 144 megabytes. This has almost 900. The question I asked in the Slack is whether, because we're seeing 900 meg of SRAM on this chip, whether it's an SRAM optimized manufacturing process. Well, now we're almost at the end. ALB, yes, it's. Oh, you go to hotchips.org, you'll see the full stat. It's we're talking about Ponte Vecchio, we're talking about RDNA 2, Xilinx is doing an Edge, and I think there's one more. It's not going to be about ARC, unfortunately. Yeah, so we're going to get Ponte Vecchio from Intel, RDNA 2 from AMD, Google's video coding unit, VCU from Google, and then Xilinx 7nm Edge graphics.
What's your minimum specification?
So because this chip has random number generation and stochastic noise, it was asked whether our results are deterministic. And he said yes, because you can set your own seeds, and it's a different seed per thread and per tile, but you can manually set them. So talk about some software question now. You haven't said anything about adoption, delete. So no real instruction cache, because you have worker threads. Not much use for caches. So part of the goal of this chip is you don't need to worry about how it goes to compute memory, because you separate your workload into doing compute or memory. Most of the time, you're doing both at the same time, like systolic arrays. So next talk is Cerebras. And David just paused. That's funny. Bugs of the day. So WSE2 in new system configs. People don't know how to take out the hiss of their recording, pre-recorded videos. Cerebras began in 2016. 2019 both scale engine. It's Natalia with WSE2. 2.6 trillion transistors. 150,000 cores. And WSE2 system is practically identical to CS1, just double cores. Costs a few million. Traditional approaches can't keep up. Dilip, I wonder if Graphcore's cluster at Azure went away because they stopped doing PCIe cards with Dell systems. So this is a log plot here, memory versus compute required. So in 2 years, neural networks have been 1,000 times larger and needed 1,000 times more compute in 2 years. Upcoming multi-trillion gram models. Something has to change in so they can need a better approach. But large models are hard to support. Massive memory, massive compute, massive I/O. More partitioning of model across more chips. More sync becomes a distribution complexity problem rather than a neural network problem. So how to solve this problem Cerebras style? Cerebras for extreme scale. New style of execution. Support up to 120 trillion parameters. Same as synapses in brain. Also needs to run fast. Up to 192 WSE2 with near linear perf scaling, 10 times weight sparsity. Speed up, scales easily with push of button. Use weight streaming rather than data streaming. disaggregate model memory from compute from data set. Can scale memory or compute as needed. I just wrote memory. Memories. I've got some memories. No, still got some strawberries. So base compute unit is a single CS2, 850,000 cores. Let's say 14 kilowatt, 1.6 terabytes second bandwidth. Add memory store to hold parameters. Weights. MemoryX. Custom memory store for weights. Independent of that SwarmX interconnect to control. It's designed to scale neural network training with linear scaling. Simple execution flow with Cerebras software stack. Program cluster, same way as a single system. Easy as pie. Rethink the execution model. All model weights stored externally, streamed onto the CS2 system as needed. Through CS2 performs the calculation. Backward pass gradients stream. Weight update occurs on MemoryX, but SwarmX can help. And now he's going through how it works. Animations. So there are terabytes of memory on this thing. Lele Socho. So they went from 16 nanometer to 7 nanometer, and they doubled the number of cores. It's pretty much it can be made very, very dense. So the more you can scale it down, the more cores you can get, the more SRAM you can get. Wait, streaming has no back-to-back dependencies. Again, it's going through a slide with multiple activation points, so I'll just upload the slide at once when it's done. Here we go. So this is how it works for those interested. Stream out waits as the next stream comes in. Hide the extra latency, extra wait. Same performance as if weights were local. Now capacity. To main capacity. Store the current model. All parameters in MemoryX up to 2.4 petabyte capacity. 100 trillion weights. DRAM and flash hybrid storage. Intel computer core weight update. So it can do onboard compute, and it's a big memory store. So Johto, it doesn't do a torus because it can scale out to. It's designed to scale and scale and scale, kind of like Wave Scale Engine. Don't think Wave Scale Engine is a torus either. It's just a big 2D mesh. No need for partitioning with WSC2. He's talking about matrix multiplication on the wafer. I wonder if Cerebras will send me a 2.4 petabyte memory system. Yeah, just some high calculations. Supporting 100K by 100K matrix multiplications. And here's the utilization graph. %, utilization. Now speed. Clustering multiple CS2 through SwarmX. SwarmX is independent of CS2 and MemoryX. So you can do an gradients reduced on the way back. Weights are broadcast on the way forward. Modular and desag. You notice it's a layered approach. Then here we have speed ups. Project near linear to 192 CS2 system. I did ask Cerebras if they actually had a 192 system scale workload done. They said no. I said, have you even sold 192 systems in the market? And he said, not yet. But I get each one of these is at least a couple million, if not a couple more. So if a one big chip does everything you need, you're not going to buy 10 of them. But you can. That's the point of this. Is this enough? No. Need smarter models. Outpacing Moore's law by an order of magnitude. Will need a football field of silicon to run a model. Need sparse models to get the same answers with less. 318 sparsity in dense models. No hardware to solve for this sparsity, except Cerebras hardware data control for non-zero data compute. Accelerates all types of sparsity. Full performance across all blast levels. So this means blast 3, blast 2, and blast 1, which are these sorts of calculations. Blast is linear algebra solvers, which are a big part of AI. Sparsity is introduced in the MemoryX unit. Sparse weights start screen. SwarmX broadcasts to CS2. CS2 does compute. Sparse gradients produced. Gradients are streamed back out, reduced through SwarmX, updated on MemoryX. All happens natively. Same flow as for dense compute. So basically, you don't need to do anything special for sparsity aside from say how much sparsity you want, or it'll optimize your workflow automatically by determining how much sparsity you need for maximum performance. So if you're wondering why I talk about Cerebras so much, it's stuff like this. It's amazing. So this is sparsity acceleration. Sparsity in this instance means your matrix multiply, enabling zeros, basically, or you make your matrices bigger by adding zeros, but that also simplifies the compute you need in your matrix. If you add sparsity to your matrix, you need to determine when you end up with 0 times 0 plus 0. And if you have that, you don't need to compute it because you know the answer is 0, and you need additional hardware usually to detect that. That's where the benefit of sparsity. If you add sparsity to make your computation more scalable, you need to be able to determine which calculations are just zeros and ignore it, pipeline it, and save the power. But you basically have to find a way to also keep your machine active. That's why it's so complex to add sparsity. Adding sparsity is easy. Optimizing for increasing sparsity for adding sparsity is difficult. That's about as far as I know it, which isn't that much compared to people who are deep into this stuff. So 40 gigs of SRAM on a chip. There you go. Enormous layer support for up to 100,000. Don't need different software to go from one device to 192. Execution model is always the same. It's if you write for one GPU, it's different to writing for multiple GPUs. Basically, the idea is that you just say, how many devices is for? Okay, go compute. Push button easy. I have seen a CS2 system, and I've seen a WOC1 chip, and I'm pretty sure the chip they're showing for WOC2 is just the same WOC1 chip. But yeah, it also does. It can also do 2D finite difference, which is fun. Now it comes to the Q&A. But there's no time for Q&A. If this happened live, we would go straight on to the next talk. So you're on mute, Sean. That's so. The questions was bandwidth memory to CS2 is over a terabit, and the internet is custom. It said it's standard, but they're not disclosing because it's not directly exposed to the user. It's intended to be integrated into the system and seamless from the user point of view. The next talk is SambaNova, but I'm going to spend a couple of minutes going to the bathroom. I'll be back in a second. Okay, here we go. Sorry about that. And they've just started. So this is a SambaNova chip. SN10 RDU, Cardinal. We've got a kind of an article on this already, or at least the announcement on AnandTech. Made it TSMC N7. 40 billion transistors. This is one of the BF16 focused AI chips for training. Base unit of compute is a 12 terabyte memory system in a quarter rack with 8 SN10 chips. Standard rack form factor. And then this is a software. So PyTorch, TensorFlow, user graph, or user kernel. So data flow pipe is SambaNova software stack. So Johto on the 3D space FEM, Cerebras has a paper on doing 3D stuff because you can have so many Z height points per core. your limit is obviously how many cores you have top to top and side to side, which is basically the square root of how many cores. So this is how the data flow works. This slide's actually pretty fun, as it shows up on the live blog. So highly optimized data flow mapping. So you have the data flow graph from PyTorch. It works out what the communication patterns should be, and then SambaNova rearranges that into a spatial compilation of data flow. Rewiring the way we think about software. Well, graphs are rewriting, not rewiring, the way we think about software. Current systems not suited for data flow. Goldilocks zone. So transformer versus GPT. So here we go to the architecture, or rough high-level architecture. So resources can be managed or combined. So it's like a disaggregated on-chip design. Direct access to terabytes of DDR4 off-chip memory. Zoom into a single tile. Pattern memory units, pattern compute units, and switches. So the AGUs go before the compute memory. Architecture allows for scale out. Here is the compute engine. So it supports starting modes of execution. It's programmable memory. CMU feeds the PCUs. Support arbitrary access patterns. So the pattern memory unit has onboard memory. Router is not just nearest neighbor. Compiler can construct arbitrary address generation units. Allows for transfer and transparent scale out. Here's how to map an operation. Communications. Pipeline operation of map. Here's something more complex, the layer norm. Graphcore also supports user kernels. In fact, most hardware supports user kernels. Johto, it's just that if you want the maximum performance, you have to go use their software path. Usually, they do push people more towards the standards because then it's easier. So. So we're talking about spatial data flow within the system. He's talking about the old way to do it is kernel by kernel by kernel, and you bottlenecks by memory bandwidth. And now we have the data flow way. You know about your spatial elements. But bear in mind, Cerebras can do it. So Cerebras does the data flow way as well. You just map the whole thing on the chip. Automatic kernel fusion. You need to manually hand fuse operations. Ooh, fusing. use IO bandwidth more efficiently. By performance, by utilization. Tony, some of them are CGRAs. I must admit, I haven't looked deeply into CGRA operation, but I know a lot of them are. I think Grok's the big CGRA. So it's a bit like a hardened FPGA, yeah. Semi-hardened. So CGRA is a coarse-grained reconfigurable array, of course. Should be coming up to. So here we have some use cases. So 1.5 terabytes of DDR4 per chip. So 12 terabyte of DRAM for 8 chips per quarter rack. Smallest compute units per sale, basically. So you have to buy a quarter rack. You can't just buy a chip. Schedule compile operations accordingly. We have better performance because we define the base unit as having 1.5 terabytes of memory. So what's that? 6 memory channels, 256 meg or gig modules, or 12 modules of 128. So run multiple applications on each node. Simple scale out. So 1/4 rack replaces 416 GPUs with 32 terabytes of HBM in 8 racks. That's 1 trillion parameter NLP training, which is natural language processing. I can't spell language, and I added a dot in for some whatever reason. There's a paper, it seems, arxiv.org/pdf/2104.04473.pdf on that slide. Might be worth having a look. And this is the thing where SambaNova tell me they want to scale workloads 50K by 50K. Support any size model, basically. Direct analysis on SambaNova. Here we go. Johto. DFT, finite difference, molecular modeling, which is, yeah, kind of what Cerebras is trying to do. So let's see. Raising performance across the board. Does SambaNova allow for multi-tenancy? Yes. That was slide. If you go to AnandTech, I think it's slide 28. Number 3 enables secure multi-tenancy with multiple, or they show 4 VMs per RDU. So if you need John, there's another half hour left. So we've just got the Anton molecular modeling ASIC left for this session. And SambaNova is hiring. SambaNova.ai. Funny, John. Hey, James. Now time for Anton ASIC 3. Anton 3 ASIC even. Sorry, stream hasn't died. They're just going from Q&A to the next session. Yes, it's meant to be raising performance, not raising problems. That was a typo. I for some reason had problems on my mind, or what I heard directly. Matt, I have watched the dojo part of the stream afterwards. It is worth perhaps doing a video on to put some thoughts down, but I've been focusing mostly on hot chips to date, so. Fire-breathing monster. Appropriate for suitable for hot chips. I look fresh because I'm the size of ravioli on your screen. We don't do full screen yet. Molecular dynamics simulation. I can't spell simulation. Discrete time step of a few femtoseconds. Force computation is derived by a model. And how do you calculate a force field to do these calculations? Electrostatic attractions. I talk about maths about force field calculations. Stuff I vaguely understand. Forces equal bonds plus van der Waals plus electrostatics. contractible to ridiculous compute. Millisecond scale protein simulation from Anton 1. Anton 2 vastly increased. It's all about the color of the logo. Here's Anton 2. Made on Samsung. Custom ASIC. Two kinds of computational tile. Flex tile and high throughput interaction subsystem. Pairwise point interaction module PPIMs have unrolled compute inside. I forgot what I just typed. Yeah, unrolled arithmetic pipelines. There we go. Periphery is the SerDes to connect multiple chips together. To make it better, need to scale PPIMs and geometry keys. Also address performance bottlenecks, such as scaling off-chip bandwidth. Also increasing simulation size support. Control the design and implementation. Anton 3 core tile. Measure router. Same GCF PPIM as Anton 2, but with evolutions. You can unroll C code, James. Use a preprocessor argument. So they've co-located all the resources into a generic tile and a centralized router. Sync functionality is distributed. wand length, calculators, and angle. Dedicated hardware. RTR is the router. Router. Keeps bond calculation of the critical path.
What's your minimum specification?
So electrostatic interactions scale with distance. So the best way to do is to partition it into near interactions and far interactions, then you have dedicated hardware for both. Nothing about time integration just yet. It's pretty. I suspect it's pretty standard though. Oh, excuse me. Sorry. Also, edge tile. So the edge network can do molecular dynamics specific compression on the data. I'm asking you a question in the Slack chat, Joe, too. What time integration scheme is typically used for simulations? global low skew clock mesh, engineered global routing. So 360 watts. Holy. Oof. 360 watt for 451 millimeters squared on TSMC 7 nanometer at 2.8 gigahertz. 110k atoms per node. 528 cores, basically. 31.8 billion transistors. They said millisecond scale on Anton 2. That's probably on a massive system, so. Here, Anton 3. It says Korea. Running simulations within 9 hours of first silicon. Taurus links for Ethernet. No, joking. Oof. 128 nodes in a rack. .3D Taurus, there we go. 16 bidirectional SerDes links. Okay, 100 kilowatts per rack. ASIC power 500 watts. Seconds per day. This is insane performance. Johto, I'm going to put the answer that they gave me in the chat. On time discretization. I think they've only scaled up to 512 node. So on the Q&A, sorry, I've been paying so much more attention to the presentation.
What's your minimum specification?
Somebody's asking you questions, Joto, about beyond 512 nodes. I'm going to end the Q&A there. Sorry, I know I haven't been talking a lot. Lots of Q&A. So I know Joto's in the chat. So go over some of the questions. Can you apply the hardware to other workloads? It's aimed at a broad set of molecular dynamics related workloads, but they haven't put much energy into beyond that. They've got some interesting internal projects. What numerical formats are being used inside the chip? One part of the hardware uses 32-bit fixed point in a general pipeline, but in the specialized pipelines, some bits are so varied they use 14-bit mantises and 5-bit exponents, and some of that is even log transforms. With regard to power management and DVFS, there's no real DVFS, but they can do some ad hoc dynamic frequency scaling through ramp limiters. It's I can't think of what it's called. When you turn on, off, on, off, on, off, or whatever. But they said they haven't needed to use them anyway. With regards to isn't the mesh, the way the mesh is doing is high power. He said out of 360 watts, about 40 to 50 watts is mesh power, and they think that's fairly reasonable. Regarding advanced packaging, this chip took 8 years to build, so it wasn't ready when they were doing a clean sheet design. So next time around, they are looking into it, and they might be working with some people who are already, at Hot Chips this year. Regarding scaling to 512 nodes, the hardware can, but the machine itself is designed to run models on 512 nodes. If you have a larger install than that, then you have to run multiple simulations, and it's for shared data. And then interconnect speeds, they said they use an NRZ SerDes link, which I put SerDes in the thing. It's a dual unidirectional running at about 30 gigabits a second, but it's still being tuned. No need for forward error correction. That keeps latency low, but they said the I is super small, so yeah. And that's where we're going to do that. I'm going to stop the Q&A there, and because I'm going to go eat, and David's still going on asking questions. I might catch that later, but it does mean that the next talk is going to be on graphics, and that's in about 45 minutes. So hopefully I'll see you all back around then. 45 minutes, grab some lunch, and then we've got, another 2 hours, then a small break, then another 2 hours. So a good 5 hours still to go today, another 8 talks. So let's keep going. Hello, everyone. We're back, and just a couple of minutes before the graphics section kicks in, I'm gonna fire up the graphics live blog here just in a second. Hope you all had some good food and are ready to tackle this next session. Ponte Vecchio, Arduino 2, Google's video coding unit, and then Xilinx at the end. So, should be the highlight for the day. Get the live blog going. We should have good stuff. Excuse me, I've still got my lunch was noodles and hot sauce and tuna. I hope you all had something as equally as exciting. And as Crispy says, get to see if Ponte Vecchio has full CXL. The thing is, Ponte Vecchio is graphics in the same way that it just does compute. So I actually still got half my lunch here to eat, so. Don't mind me. And I will say that there are bugs coming into the office. 10:30 at night. You can't use Ponte Vecchio as a CPU, no. I need to promote this on YouTube. The tweet has gone out. And the stream is starting. Let me move the stream down. And there we go. Xilinx is more about video, because just like Google's is more about video than it is about graphics. Working on graphics. And David Blythe, Intel GPU architect. And he's reading off screen. And don't mind me eating during this. And for 500, aiming for 500x over Intel's previous best GPU. And then the middle bit is scale is very important. we're going to see a lot of what we had at Architecture Day on this one. But you can tell David his camera's here, right in front of him, but he's reading the screen down here, so his eyes are all down. For variant XE, and HPC is the one we're talking about today. Scale market needs scale. Broad set of data types. 4 building blocks, 4 slice stack and link. And then the XE core. No longer EUs, XE cores now. Really right-leaning? What do you mean? Each core in HPC has 8 times which have bit vectors. A deep systolic array. Large 512 kilobyte L1 cache per XE. Software configurable scratch. Add shared memory. Here are the data types for the different engines. N92 int 8 per XE core. One slice has 16 XE cores, 15 RT units, 1 hardware context. Proviz and content creation. Give me a PCIe card with it on then. Come on, PCIe card, please. Stack is 4 slices. 64 XE cores, 64 RT units, 4 hardware context. L2 cache, 4 HBM2E and controls. Eight XE links. Copy engines, media engines. Two stacks. Connected directly through packaging. So this is a Ponte Vecchio, isn't it? then Xilinx. CPU to GPU communication. 8 fully connected GPUs through embedded switch. Not for CPU to GPU. So here we have how it links together. Sorry, how it connects together. For GPUs, it's going to be a popular configuration. 6 GPUs per node is Aurora. So 8 GPUs in OAM. OCP accelerator module. So you can get 1 million int8 ops per clock with in one system. And now here's Ponte Vecchio. Not Ponte Vecchio, Ponte Vecchio. Advanced packaging. I think Dan's got the right idea. Just look at it and slam an entire bottle of scotch. Johto, the same slice will be in HP as well, I think. It's meant to be for pro visualization, so that's why you also need ray tracing. Lots of new stuff. Advanced packaging like EMIB and Foros. Five different process nodes. MTFI interconnect traffic. Learned a lot. So they had to lock the floor plan in early because of Foveros, and they had to run Foveros at 1.5 times the original frequency in order to minimize Foveros connections. booted a few days after getting the silicon pack. Order of magnitude more Bogaros connections than other previous designs. Built on TSMC N5 compute tiles. Oh, L2 cache per base tile is 144. .640 square millimeters per base tile. Built on Intel 7. AC tile built on TSMC N7 with 90 gig SerDes. XC Link tile built in less than a year. And here we have the form factors. They're not called execution units anymore, they're called XE cores. And ALB 92 factory tours this year, unlikely just because of travel restrictions. Also, factory tours are a little boring because they're all the same. It's more the test and bring up where it's more fun. Sorry, I'm still eating my lunch. Base tile has a lot of the control in the L2 cache in Ponte Vecchio. And then one API support. Went one API 1.0 gold Q4 last year. Eric, you have to stop asking that. Everything plays Crisis. CPU version. Bit translation. A0 silicon, 45 teraflops of FP32, 5 terabytes of memory bandwidth, and 2 terabytes of connectivity. That's all EMIB bridges. Is 640 square millimeters? That's large for 144 meg. Correct me if I'm wrong. I see some performance numbers as well. XE tiles made in a year. That was interesting. The fact they had to bundle it into TSMC was N7. It's interesting. customers early next year. Then after Q&A. Or CXL. So first question was, if it's 45 teraflops for FP32, is it also 45 teraflops for FP64? And he says yes. So John, that question was a bit weird. So question was, does the Xilinx support CXL? If so, which revision? And the correct answer to that is the Xilinx doesn't have anything to do with CXL. It's the chip does CXL, not the Xilinx. Okay. Xilinx bandwidth. Two. Okay, so does the GPU connect to the CPU by PCIe? CXL says PCIe. What is the Xilinx bandwidth? It's 90 gigs using the 90 gig SerDes. I asked a question about peak power and TDP. He said it's more an architecture discussion, so they're not disclosing. That's a product specific number, and when they start talking about products, they'll start talking about that data. So next talk is AMD. RDNA 2. Xilinx is proprietary both on the physical layer and on the protocol, at least as far as we know. So NVLink was also meant to do CPU to GPU, Amnon. Xilinx is just GPU to GPU. Xilinx has nothing to do with CPU. That's what we've been told. Yeah, no power numbers. AI 100 can also go up to 500, 600 watts. So let's put it this way: the Aurora blade is liquid cooled. The open standard version of NVLink in Xilinx is PCIe. Xe switching silicon has switching compute, I imagine. RDNA 2, a flexible and adaptable design. Let's talk products. Well, RDNA 2 has been out for a while, so do you see anything new in this presentation? Not sure. "18 months after first RDNA product." Oh yeah, the open will be CXL, but CXL is not quite Xilinx and it's not quite NVLink. RJ unshackled the design from certain underpinnings of GCF. What is key metric? Minimize wasted power. But everybody does that. Why would you have waste power? It's all about trade-offs. It's what you're willing to accept versus what you need. And support for direct storage. Just talk about RDNA 2 and why it was developed. So next gen consoles helped with the development of feature set. So high frequency design versus RDNA 1. Plus 30% frequency at ISO power, or under half power for ISO frequency. So that's what this graph says. Potato, James Pryor is saying a potato link in the future. Thing is, a potato link has a mashing function, and everything you put in that's perfectly aligned comes out as a mess. So you got to be careful with what you put in the potato link, or it comes out deep fried. Depends how it's feeling. You need to chip your data, and then it will come out a bit crispy. That's potato link. So all this RDNA 2 stuff done without changing process node. Talking about power and oh, here we go. Cache. High bandwidth, but low hit rates. So RX 5000, RDNA 1. trying to avoid GDDR use to reduce power, so increase caches. Brian, you're right. I'm more interested in CDNA. We do need more insight into AMD's compute cards, but so GPU cache hit rates. Graphics used to be 1 pass compute. Nicholas, CDNA is the compute version of Radeon. Just need cache chiplets on top of your GPU. Big L3s, no, big infinity caches. Marcus asks, aren't CDNAs going to be used in exascale? Yep. Yep. Though I really wish AMD's software stack was easier to compute. Mind you, I haven't looked too much into ROCm compared to what I used to use for CUDA. CUDA was easy to get working, especially if you use something like Visual Studio, to the point where I got it working once and I never updated it, and I air-gapped that system. So nothing can update it, nothing can get in the way. And that's what I did my PhD with. Never connect to the network, never a problem. So here we go. Here's some insight into cache misses. So lower energy per bit. Only 1.3 petajoules per bit on cache versus 7 to 8 petajoules per bit for GDDR6. So factor 5. Average memory latency on RX 6800 is 34% lower than RX 5700, both using GDDR6. Yeah, Johto, ROCm has Hipify. I know that much. I've been asking about Hipify for a while, because it's always about trying to catch edge cases. So here we go on performance per watt over RDNA2 and GCN. Ray tracing in RDNA2. Variable rate shading. Sampler feedback. And mesh shaders. Mark, I have said Nando. Or Lando. I'm surprised Lando Norris doesn't go by the name Nando. It's talking about these 4 features. I think everybody here should know what they are. There we go, ray tracing. RT aim to be efficient without adding overhead. Tightly integrated into the shader architecture. Streamlined implementation.
What's your minimum specification?
Are you not one for VRS, Nick? I think VRS makes sense. Though I do wonder how the GPU determines what's relevant to do VRS or not. Seems a bit weird. And why doesn't VRS go beyond 2x2? I guess it's because it's limited to an 8x8 grid. You can't really... After a 2x2, the only realistic ones are 4x2 and 4x4. Why don't they make it a 9x9 fine grain block? How about that? Anyway. And here we have the RDNA2 variants. You know, the 3 cards. Let's talk about clock speeds and power and memory bandwidth, 256 bits. Show you that's memory bus. And then it's over to Q&A. Oh, this talk finished relatively quickly. 20 minutes.
What's your minimum specification?
I asked the question about Steam Deck, Nick, but we'll see if they get to it in the Slack. Talking about, it's a generic question about what proportions of things they need in, you know, compute and ray tracing and cache and that sort of thing. So pretty generic. And traversal in the shaders and ray tracing in the shaders rather than dedicated units. Question of stacked Vcache. So why is the Infinity Cache on die rather than stacked? And the answer is because they were only really considering on die cache at the time. So TDP percentage as CUs versus other.
What's your minimum specification?
Question was, what percentage of power is based on the compute units? And he said, well, it depends on your workload. No shit. The whole point of that question is peak. Don't ever say it depends on your workload. Everybody knows it depends on your workload. Oh my god. Everybody knows it depends. We ask that question knowing it depends. We say, given that workloads depend, what is the... It's implied. Oh my... Sorry, I'm getting tired and irritable because that sort of answer to the question really annoys me. Steam Deck question. I know, but that's not the point of the... Oh, God. And now Tom from Oslo is Dead is asking, what are you doing for next-gen products? Oh. I'm not going to answer that. That's a stupid question. Nice. Oh. Now I'm getting very irritable. So, okay, I'm going to mute this and say what's just happened. Okay, so I asked the Steam Deck question, is there anything special about the implementation in the Steam Deck in the Vecchio APU? And he was like, no comment, go check the public available data. It's like, well, no, duh. We know the public available data. Ask if there's anything special in the implementation, not the implementation itself. And then Tom from Was Lawyer is Dead is basically saying, in future products, how are you going to manage the memory bandwidth? Are you just going to use faster GDDR6? And his answer is basically, no, but I'm not going to talk about future products. Why are you even asking? Okay. Let's reset. Let me turn the audio back on. Last question. Oh, I can't find a question. Yeah, so we're not whenever I go to a presentation, whenever there's a Q&A, there are so many questions where it's like, oh, we didn't talk about that. It's like, well, no, you didn't talk about it. This is why it's a question and answer session, because I'm asking you questions about stuff you didn't talk about. But there's a fine line between that and basically going, well, how are you going to improve next gen? I mean, I asked a question. The question I asked, which wasn't asked, was what's the low hanging fruit in the design, right? And that's different to ask, what are you going to solve on next generation? That's how you ask those sorts of questions. But I do go into briefings and I ask questions and be like, oh, we or don't want to talk about it. It's like, well, I'm not talking about the product level. I'm talking about implementation. And this is the downside of this sort of interaction. Having all questions go through. I mean, it's the only way we can do it virtually. But if we were in person, what Hot Chips normally does is there's microphones, and you go stand and line up in front of the microphone, and it means that you can have a little bit of back and forth. And so if there's a misunderstanding of the question, which does happen sometimes, or they don't answer it exactly how you want, you can decide which you can decide to correct them or say, or no, I was actually asking about this and this, and sometimes they turn around and they say, oh yeah, okay, now I know what you mean, I'll talk about it, but in this context you can't. And it's relatively frustrating. So if the answer to your if you ever answer the question, oh, we didn't speak about that in the slide deck, that is never an answer, and I will always come back and say, well, of course, you didn't mention it. That's why I'm asking about it. And then they laugh, and then I laugh, but then I'm like, no, seriously, what is, are you going to talk about this? Because if your goal is only to ask questions about what you've presented, then you don't want questions. Yeah. Optimize your questions. Think about what the other person can answer, what they're willing to answer, what you expect to get out of it, and tailor your question to do that. Though it doesn't take from the mind-numbingness you get out of the person answering. Mind you, do give them a little bit of slack answering questions on the fly when you don't have any. Well, I mean, they're all in Slack. You must have seen some of them, at least. But yeah, sometimes you don't offer the best answer first time because you are thinking on the fly, and just like when you're streaming, you sometimes forget exactly what's going on. But that being said, let's go on to the next talk, which is Google's video coding unit. Talk 3. Yep, Google next, Johto. This is a topic I've got the research paper. I wanted to write it up. I wanted to do a video on it, but I spent too much time reading it and not enough time actually writing about it. Actually, Dylan Patel over at Semi-Analysis has a really, really good write-up of the VCU. And arguably, I just want to turn his article into a video. That's all I need to do. Oh, Joseph, yeah, I do know that there's, engineers are not allowed to talk about anything they want, but SlideXverse is talking about it. That's why there's, if there's not a Q&A session, then that's it. So, and yeah, what's your minimum question specification? Video is greater than 60% of global internet traffic. So they've got YouTube, TikTok, Vimeo, Zoom, Teams, Google Meet, GeForce Now, Stadia. Need better algorithms. I would like to get hold of a VCU. The video is getting hard to compress. AV1 is 200x more time consuming to encode in software versus H.264. And then pixels per second has increased 8,000x since H.264. Most consumer hardware is optimized for cost, not performance or efficiency. That could not find everything in off-the-shelf offering. Encode tens of versions with one input. Is anybody who's watching the stream hearing lots of pop-ups? I'm getting a lot of pop-ups. Jeff, the paper on this is great. The research paper on this is great. It's well worth the read. I think it's behind a paywall. Is it? No, it's not behind a paywall. This one isn't. I know a few others are, but so this is deployed at YouTube already, or through Google. Yeah, pop-ups in the recording. It's because they're also recording local. I've done that a couple of times, so. I've accidentally recorded videos where I'm also recording the OS sound and I don't notice until I hear it back and I either have to record it again or if I'm feeling lazy, I leave it in. So while Jeff in the chat can spend a few days, a few weeks on a video, I want to get it done in an hour and a half, recording, edit, and post. Crispy Silicon, there was a VCA on eBay recently for $700. I couldn't justify buying it for the channel. Not yet. I need to grow to like double or something, so. It's Astarion. This is my 7th. This is my 7th hot chips, I think. I should have started going to it earlier, but it was a knowledge thing. I didn't realize what it was, and I only saw it after the fact. It might. I think one of the other presenters has left the microphone on. Jeff, I think my longest video from recording the first bit to recording the last bit is probably 24 hours. I want to make sure I have everything before I start recording. But even then, I've done 2 scripts ever. Almost all of my videos are to camera off the cuff. It's very different to the way you do it, mate. Sorry, just talking about internal video architecture. Yeah. High-level design synthesis. Enabling software, hardware co-design. This would be the sort of thing that AI-enhanced EDA would help a lot with. Is it by chance the atomic clock video, Jeff? Linus just put his out. It's unfortunately a lot better than mine. The problem with scripting my videos is I don't have a what do you call it, where you just read off a screen. My camera is further away now than it used to be, but I don't have a teleprompter. Yes. I'm pretty sure Anthony wrote the Linus video, so yeah, rubidium clock. It's not a radioactive rubidium. That's atomic. Yeah, it's because he's playing off the word atomic. A smoke detector is more radioactive than that. So this presentation, he's talking a lot about, you know, how they decided to do. It's, come on, speak more about chip. Yes, John, I do know why MRI is called magnetic resonance imaging and not nuclear. But now we have VCU ASIC. This is what we want to see. Let's talk ASICs. Oh no, this person is very monotone. And again, so am I, so I'm one to talk. Accelerators need to scale to warehouse scale computing. tolerate errors at chip and core level errors. Reliability is a higher level function. I use a different word, I can't remember it. So, need to support 48 encodes per decode, which is called an MOT. So if you upload one video to YouTube, it encodes it into up to 48 different versions. It can be 1 to 1. It's usually 1 to 7, 1 to 8. They can do 1 to 48. That's what this is. Thanks, Jeff. Have a good one. Chip level cache was ineffective. Core counts to support large MOTs, so multi-encode. LPE DDR4 for bandwidth per byte. On chip memories use ECC. Conservative knock design. This is the firmware. A single decoded frame can be multiple times. So one decode for multiple encodes. Parallel queues for high utilization. Two ASICs per boards per chassis. Two chassis per host. As many machines per rack as space and power allow. Performance versus dual socket Skylake. Basically 100x BP9 versus H.264. Oh. 1/10 of power. One 20 BCU machine replaces racks of CPUs. Power. I think they've mentioned power in the paper. They've put 2 chips on a single PCI board. I don't think the PCI board had additional power. So we are talking about. Let's see. Oh no, there's an 8-pin per board. So 225 watt max for 2 chips. Post-deployment improved quality. Time for Q&A. 10 minutes for Q&A. To be in tandem with ASIC. So chips and cheese are here. Not possible. No intermediate tap in, tap out. Tightly coupled in. UX, you have seen the what's happening today, right? What time it is? Chips and Cheese is a hardware blog run by 4 guys, who some of which may be in the industry. So first question is, can you use the VCU in tandem with an ASIC? And sorry, I'm talking over him and it's quite loud. And they said not possible. There's no intermediate tap in, tap out. It's tightly coupled design. Second question was, what's PCIe card profile? How many lanes? What TDP? They said it's a full height, full length dual slot. Post silicon power measurements around 100 watt, but it does have an extra, PCIe connector if needed. Another question was, will the VCU be enabled by the Google Cloud platform? And they said, will the VCU be enabled by Google Cloud platform? They said, we're always looking for unique features on the Google Cloud platform, but no announcements at this time. This this chair is just literally asking questions as they were top to bottom. He's not checking which ones are upvoted, just top to bottom. What, Nick, about YouTube competitors, Floatplane. That's not the question. Oh, for God's sake. Right, okay, so next set of questions. If you do HLS design, can you draw parity with RTL? The answer is yes. I asked if the ECC caches are sec dead, so single error correction, dual error detection. He said where possible sec dead, although there are some SRAMs in the encoder that for speed reasons can't do full ECC, they only do detection. However, if an error does occur, they can reset the job. I asked a question, can you do 8K60 on a single VCU? And he said, throughput-wise, yes, but technically there's no VP9 profile that supports 8K60, but on throughput, yes. I did ask about other codecs. I meant in hardware, though. The chair didn't ask it in terms of hardware. And he just said, are you doing other codecs? And he said, no comment on future formats, heavily involved in AV1, next-gen AV2. That's not what I asked, but another thing with these presentations is if you ask a very specific pointed question and the chair doesn't get what you're doing straight away, they butcher it, unfortunately. So I'm thankful he asked all three of my questions, but that third question was pretty butchered. Another question is audio streams. Does the VCU do audio streams? And they said, well, when they get in a video, they actually chop it up, both video and audio, and then the video could be chopped up even further. And all those different parts could be spread out and broken up and be processed elsewhere. The VCU doesn't touch audio. They have dedicated audio inside, the warehouses, inside the data centers that do the processing there. And then, it all comes to be recombined. But the point is they can chop up audio. That's why when you upload a video to YouTube, and you might think, well, how can they encode it in 20 different formats in a minute? Well, it's because they chop it up into 1,000 segments and they can submit it to 1,000 systems at once, and then they recombine it. And the recombining is almost as easy as just adding concatenating files. So, fourth talk is Xilinx. And the microphone has a buzzing. Somebody needs to plug it in properly. That buzzing's terrible. Sorry, there's a 60 hertz buzz.
What's your minimum specification?
Somebody's microphone isn't plugged in properly. If anybody can hear me from the Hot Chips team. You need RTX voice to cancel out the buzz. This is Xilinx Versal AI Edge family, 7nm. I've spoken about it before, so. Or is it 50 hertz? It's in the US, so it's 60. If it's in the UK, it'd be 50. That's the way around, right? AIE ML architecture optimized for buzzing has stopped now, thank God. And yet again, we have another slide of what is machine learning used for? Yeah. Yeah, it's gone now, John, I think. I can't hear it anymore. Either that or I've already tuned it out mentally. All of these applications require low latency and low power, and this is why we have our product, because it satisfies them all. Because if they said anything else, it wouldn't be. So if you think Xilinx just does FPGAs, this is their new version of FPGA. It's a combination of FPGA, but also lots of hardened implementations. So you've got dual ARM Cortex cores, management controller, accelerator, RAM, video decoder unit, MIPI, Ethernet, SerDes, DDR4 controllers, PCIe Gen 4, C6 support. It's basically, you still have your big FPGA, and you also have AI engines and dedicated DSP engines configurable. And you have all your FPGA stuff on top of that. So the what is machine learning slide is getting as bad as Intel's pyramid of Optane. I always joked with Intel, it's like every time you present this to me, and this is like the 30th time, it's always the pyramid of Optane. And if you've is it The Office where they speak about, the triangle? It's the triangle of Optane. Yeah, okay. 2 new devices into the market. They're not introducing these today. These have been out for a while, but a low-end and a high-end device. John, 1 year we're going to have to submit a joke talk, and it's basically how to write, what you should present in a generic hot chips talk. And we'll just get up and do something like that. Somewhere between the DoE and somewhere between... What's the opposite of DoE talk? What's been the best hot chips talk? That's a difficult one. I've always been on the list. Johto, this is inference stuff. This is designed to be low power, high volume, high yielding. You want the big ultra scale plus VU19P. That was on the latest, and I assume the equivalent will be on next gen latest. And now we can't change slides. Maybe? Oh no. You gotta have the slide thanking 1,000 people. You gotta have a slide with the research paper that nobody's read. Oh. Lots of different form factors for reference. Dual M.2, E1S, E1L. Oh, we're going to have to mention blockchain, right? And quantum. Oh, John's already beat me to it. And low cost.
What's your minimum specification?
So these chips support int4 inference. And now my stream is buffering. Either that or my whole internet has gone down again, as it did yesterday. We'll see. No, just stream has paused. Hot chip stream. Oh, there we go again. Wi-Fi direct to L1 cache with DMA access, Nick. That's what it's all about. Or we should have a slide saying Nick's Nick. SRAM is ECC protected. Memory tile amount depends on device. Mid-range is about 38 megabytes of memory tiles. Yeah, it's now midnight in the UK. Oh, lowest latency. Always have to mention lowest latency. Linear scale out. Optimized software stack that supports Onyx. But we have our own software ecosystem that you have to use to get the best performance. That's always what every talk has to have, right? Well, we developed this with no standards, and we're committed to working with other partners to make it a standard. That's always a good one. Bitwise translation of x86. It's always a good one. And to any question they ask, just say, we're not discussing it. Things not to do, tell the person asking the question, did you read the slide? So. Dileep is saying Amazon has banned PowerPoint. Why don't you just export as PDF? I'm really yawning now. My ice 40s are over there. I can't reach them from here. Janus, if AMD are smart, they'll leave Xilinx alone for a couple of years after it goes through. They'll just leave it alone for a couple of years. Just let it do its own thing. Start selling Epics with Xilinx hardware, before they start doing any sort of synergy, really. John is saying that there are too many VLIW vector ML cores out there. Thing is, VLIW really needs compilers to work properly. I mean, it works if the compiler works properly, but if you hit an edge case, it doesn't work that well at all. I can guarantee that every library being developed uses VLIW well, then sure. Elbrus also does bitwise translation of x86 and Marvian. Russians can do it. Nick, I don't think AMD's looking at optical, at least they've not mentioned it. Obviously, Intel has their integrated photonics division, part of Intel Labs, and that is going great guns. They've got some really good stuff going on there. It's another video I should have made after Intel Labs Day last December, but I haven't got around to it. It's so many videos that I need to do. Right now, the presentation's talking about this slide about different matrix multiplication stuff. Nicolaus, for one run of software, that might be true. Compiler taking more compute than the software. But if you're scaling it across thousands and thousands of customers and thousands of platforms, and it's going to last for 10 years, then yeah. Zetharion, it's not just time in the day. As most creators will say, they also need clones or people that they trust to do things like edit video or edit scripts or deal with merch, and though technically those are called employees, but we'll see. Has anybody got a link to the XKCD comic about automation? That's always that's why compiling is good and automation is good. So he's still talking about the data flow in this slide. That's why I haven't written anything in the live blog yet recently. Tiles can't read direct from DDR. No, it needs intermediate levels. Johto, it's 12:05. It's how much time, rather than the automation one. Which one's 3:03? Yeah, no, 12:05. That's the one I want.
What's your minimum specification?
It's coming, Nick. It's coming. I think they're almost there. But the problem is, it only makes sense if it's better than copper. And copper is doing great guns right now. That's half the issue. The hardware is almost there. It requires packaging, which also puts a minimum on the cost. But Intel is going to be implementing optical connections at some point. I also need to ask about power. Power might be a bit of a concern, but they've miniaturized so much needed for optical connections. Speaking mostly about the ML core here, it's not really anything to do with graphics or video, so. Johto, I don't know. I don't have any insight into radiation hardening. Don't forget, optical also has the added issue of jitter, because even though you've got an optical fiber, there are variable paths within a fiber that the photon can take. So, or wave, or whatever you want to call it. So you will get a variation of nanoseconds along wire of that jitter, whereas with copper you don't get that. You get a delay, but you don't get jitter. With an optical fiber, you get jitter. As long as you manage that, you're fine. Maybe I should do a fun video on snacks. I'll add it to the list because I'm tired enough to consider it. So because there's a local distributed memory in these AIE ML cores, no cache misses, higher bandwidth, and there's no duplication of data. Zetharion, if you want to consider how good your memory is, there's a test that I was told by a therapist or somebody at some point, what you do is get a friend to think of 20 words that are between 5 and 8 letters long, and not let them tell you. Then get them to give you that block of 20 words, and you have 30 seconds. Try and memorize as many as you can. After 30 seconds, you take that list of words away, and then you wait another 30 seconds, and then you have to write as many as you can down after the, so after a minute after they've given it to you, 30 seconds after they've taken it away. And you've got a minute. Make sure the words that they choose aren't try and make them as unrelated as possible. And the goal is, how many can you remember in that time? The average person should do should do 7. And then 99% of people will do between 11 and 3. So your standard deviation is 2. So 2/3 of all people should get between 5 and 9. And if you get higher than 9, then you're kind of you're in the top third, top 6th of memory. And they use that as an indicator for being able to remember things. So that's a fun test. And I should actually get back to listening to what this talks about. It's getting that time in the day. Coming soon to the software stack. Oh, look at distraction. Yeah. So, I mean, I've sat on briefings about this Versal AI Edge AIE ML cores before. And I didn't write it up at the time simply because I didn't think it was that interesting enough for the audience. So we'll see. Yeah. Wait until at least the end of the session, debating whether to do the next session at all, because I am exhausted. And the talks don't seem to be that relevant to what I normally cover, so if I was on Pacific time zone, then I'd be more awake, I guess. So it is getting a bit late. What is it? Almost 4:30 Pacific. Yeah. How to use a full Versal AI Edge processor for a single use. So this slide is basically saying you can use different parts of the Versal AI to do all these different things on this slide. Yeah. Oh no, I loaded the wrong one. There we go. Crispy Silicon, yeah, there's a timer on the stream just above where it says scheduled day 2. I did that on purpose because people were asking where we were during the day, or they didn't know what Pacific time was. So Ron, interesting. Yeah, Amarvia, a lot of us have asked for 3 days. Their big worry is that if they do it over 3 days, people will skip a day, or people will skip sessions. fewer people will be interested. They want to keep it a small conference, as in just very much just the best over 2 days. And unfortunately, they're accepting so many talks because, I mean, 5 years ago, there wasn't machine learning sessions. They were like mini SOCs, and some people would go to those sessions. Not the thing is, with the machine learning sessions now, they're 2 sessions over the 2 days, plus talks like this that come into the graphics section. So they could just do a machine learning day, and that could just be day 3. But the thing is, where would you put something like the A100 from? If they were going to do, if NVIDIA was going to do a presentation on the A100, would they do it in graphics? Would they do it in compute? Or do they do it in machine learning? It would be depending on what the marketing would want to do. See what I mean? Nick, the answer to your question about the goal of most of these AI designs, with training especially, Jim Keller had a good answer to that, in the fact that you have to have a proof point of 1,000 before you can sell 10,000, a proof point of 10,000 before you can sell 100,000, a proof point of 100,000 before you sell 1 million. And unfortunately, a lot of AI companies are targeting the million cloud service provider deployments out the gate. That's the issue that they have. I think that's primarily Graphcore's issue to a certain extent as well. But would I skip day 3 machine learning day? I might end up skipping half of it, but it'd give me time in the other half to have meetings with other companies during the show. It would give me a chance to go see the posters, because I've only seen a couple so far. I mean, there's lots of things in the Slack I haven't, discussions in the Slack that last year I was actually part of it because I'd miss out sessions. But this year I haven't, partly because of the stream and partly because there's been so much to discuss. I mean, there have been so many sessions worth covering. So, I mean, if it was in person, if there's like a block of 4 presentations, I might live blog 2, and then the other 2 I'd go off, go have something to eat, go have a chat, go have a meeting, meet somebody in the hallway. You know, and that's arguably where all the best conversations happen during an event like this. Oh, Jed, hope you feel better soon. And Dilip says 2 days is enough, not enough quality submissions for 3 days. So instead of having, 14 talks per day, we had 9. Same number of talks, but over 3 days. We're not saying expands the 3rd day with another 12. I'm just saying take the same number, but spread it over 3 days. Yeah, some people do fall asleep when it's in person. Zatharian. Nick, in person, it's usually $500 in person? Maybe more? I don't know. Dilip, do you know how much the in-person hot chips usually costs? Because the issue is I always get a press pass, so that's a point. If next year we get to be sponsors for the event, excuse me, I do get 1 pass that I can give to somebody, and perhaps we can have a giveaway for that. Or I'll give it to the student who I think is working on, who submits something. I don't know. Yes, it will cost more. Will says TechTechPotato conference when? Oh, not anytime soon. Yep, need to rent the facility for 3 days, but I think that's doable. Now we've got a Q&A. But I'm going to skip Q&A because that's it. Kind of done with this talk. Sorry, Xilinx, if you're watching. Sorry, Tara. Sorry, Brian. what the price for previous conferences is on the website. Price for this conference is, price for previous conferences it isn't, and I just can't remember in person being more expensive. Will, the problem with doing a TechTechPotato conference is that, consider my working week, it's about 80% to 100% AnandTech, because that's what pays the bills. So that leaves me 20% to work on TechTechPotato, or less than most weeks. So yeah, it's doing the channel at the minute is still a long way off what I'm paid in my day job. So a lot of people do sometimes ask, when are you going to do YouTube full time? I'm not anywhere near that, unfortunately. Marvir asks, when are you going to team up with the Anton team? So I put a message out and they said, well, we're all still working from home. But when stuff gets going back to normal, message. But they did also say that they're not too keen on press coverage, which is going to be fun. So that means I should definitely do a very large written write-up and video about Anton. About the Anton chip.
What's your minimum specification?
And yeah, Earl's Court is very expensive. I was right nearby the Hammersmith Apollo the other day. Is a Tharion. Okay. To compare me to LMG, look at my atomic clock video, the first one. And after a week, it was at, 15,000 views? His video was at 300,000 after 3 hours. So 20x the views in 1% of the time. So that's 2,000x better efficiency. That being said, I'm not sure what the arrangement was they had. I think they got connected to a different guy. And the thing is, they also did do spectroscopic testing with the card. I just talked about it. So today, actually, where we are on viewership, we didn't peak as high. We only peaked at about 130. We actually had 360 yesterday. And about half the number of playbacks. The thing is, yesterday was CPU, and that usually pulls in a lot of people. Today's been more machine learning, and it didn't really pull in that much. We got a nice bump after the graphics, and hovered around, mostly around 100 for most of the day. And then since Xilinx came on, it's kind of been a drop-off. So, yeah. So, technically, we're just finishing graphics. We're now moving to break. The new tech section is, what's it here? It's AR contact lenses, a Samsung image sensor, a university nanotactile sensor chip, and a quantum computer company doing ions, doing ion qubits. Quite frankly, I'm not too fussed about the new tech section. Where is it? Yeah. So, because it's gone midnight, we've been going for 8.5 hours today. I'm exhausted, and yeah, I think I'm going to go sleep, honestly. So I'm not going to be covering any more of Hot Chips today. Sorry, guys. It's been a long slog. It always is every year. What made me do such long live streams this year, I have no idea. I thought it'd be interesting. I thought it'd be something different for the channel, something different for the coverage. Everything's on AnandTech. With the live blogs on AnandTech this year, I decided to do it per session. In previous years, I'd do it per talk, and that was just a hell to get right and ready. So this year, let's do it by session. And then we did 1, 2, 3, 4, 5, 6, 7, 8, 9 live blogs. That's 3 keynotes and 6 sessions. So yeah, not going to cover the new tech. I hope you guys all enjoyed. I guess, what is it, 19.5 hours of live stream coverage over 2 days. And yeah, big thanks to everybody who's been around. Even if you've only just come in and you've been 10 minutes, and for all of those who were here for 11 hours yesterday and again for 8.5 hours today. Also, let me know who was actually at the conference and didn't find me talking over them to be too bad. And also, if you weren't at the conference and you're following along, how was it? Were you able to follow along with some of these slides? I know a live blog and I know a chat like this isn't the full experience. Unfortunately, it's not meant to be, because otherwise, why would anybody pay to attend aside from the Slack? But I know a few of you asked questions, and I did try to submit some of them, and some of them got answered. And maybe that's it. Also, any of the talks that you saw, let me know who you found most interesting and who might be good for an interview. When we, like I say, I've got an interview with Art from Synopsys. I think that's on Thursday. I'm going to try and nail him down on some stuff so he's a bit more concrete in what he says. And he was when I spoke to him last time. So let's see if we can nail him down. That's going to be, that's an hour-long interview. So let's see how that goes. But there's a few others here, definitely worth talking to after this. Yeah, the Anton team. That was, excuse me, after writing and learning about machine learning chips for so long, you understand what everybody's doing. And then you see something like that Anton ASIC, and it's just mind-blowing how different an architecture has to be for exactly what they're computing and how they've, divided it. But yeah, and like we said at the beginning of the stream, there is a Synopsys t-shirt you can get. Let me bring that back up just so people can see. Let's see if I can get that image back up. Where did it go? Because I do want you guys to get something out of it, and if we're going to interview Synopsys, then I can't remember what the exact link was. cut.ly/hot chips presentation or something. Oh yeah, Nicholas has a. If you've got questions for Synopsys, please ping me, Ian@anandtech.com, or tweet at me. That might be good. IBM TELUS. It would be nice to get Dr. Jacoby on for a chat, speak about the future of IBM Z, IBM Z. The PIM, Jed's saying that the HBM PIM. The funny thing is, I've now had 2 briefings on that, and I'm always the one that asks a lot of questions, and he's answered all the ones that I put to him. I don't think I have any more questions to ask him. It would just be a generic interview asking the same questions. And Namsung King he answers questions really well as well. So Evan's still saying that they won't accept the EDU email. I didn't get an answer, I don't think, on the keynote. No, I didn't. I will send that email. I did have it written. Maybe it's still up. Evan, do you mind saying what EDU? It might specifically be a they don't like that university. And for all the new people who are joining, we're just about to quit, unfortunately. And Crispy, thanks for the $5. Yep, I have to close my eyes. And Nicholas, thank you for the $5. It's all going into the fund for sponsorship next year, and I think all future streams we do. I see you, Will. Don't worry. Let's. Is that it? Oh, it's not. It's not that link. It's something else. But University of New Hampshire. Oh yeah, John says if you've got a Google, try it at googlemail.com as well. And ich bin da, yeah, I am located in the UK. So. I've sent an email to Synopsys for that t-shirt, so keep it on a tab and refresh it over the next 48 hours, see what happens. But yeah, I think that's it. Let's call it a day. I've got at least one video I've recorded that I need to edit, and there's definitely a good couple of other videos out of this that I should probably try and get done tomorrow as well. So thank you all for coming. And I didn't eat my hot chips. I've still got all my sauce. But I have easily gone through more than half the Pringles and lots of beverages. And I hope you guys as well. Thank you all for attending. And see you in the next video.